Now there is a differential equation which is given to us, and that is dy by dx is equal to 1 minus cos x upon 1 plus cos x. Okay, so this is the differential equation. Dy by dx is equal to 1 minus cos x upon 1 plus cos x. Now what we need to do is we need to specify the angles first of all. What is the angle over here? This bracket, this is the angle. Okay, this is the angle, and we need to focus on this angle only, x, the conversion of x, we need to focus on that. Now the x, it can either become 2x or x by 2. What is more easier to us is conversion of x to 2x. Conversion of x to 2x is more easier to us, right? Conversion of x to 2x is more easier to us. Now in order to do this, what we are going to use is we are going to use cos x conversion to 2x. For this purpose, we need to engage into multiplication and division of 1 by 2. Okay, 1 by 2. What are the two identities that we should know to solve this question? Cos 2x is equal to 1 minus 2 sine square x and 2 cos square x minus 1. These are the only two identities of cos 2x. Now what we are going to do is we are going to convert the angle. What we will do is we will divide this 2x by 2 so that we can get x, cos x. Okay, now for the first case, let's do this. Cos 2x is equal to 1 minus 2 sine square x, right? Now the angles, I said, they will be divided. Okay, they will be divided. Only the angles will be divided, the other substituents will not be divided. Okay, so this is cos x equals to 1 minus 2 sine square x by 2. Okay, now this cos x plus 1, sorry, this is 2 sine square x by 2 equals to 1 minus cos x. Okay, so this is the first equation that we have got so far. Okay, this is the first equation that we have got so far. Now for the second equation, we will write this: cos 2x is equal to 2 cos square x minus 1. 2 cos square x minus 1. Now 2x is the angle and x is the angle over here. We are going to divide within the bracket. Okay, cos 2x upon 2 is equal to 2 cos square x by 2 minus 1. Okay, so what it will, this 2 and 2 will get cancelled out, this substituent and this will not, these two will cannot get cancelled. Why? Because this is within the bracket and this is the angle and this is the substituent outside, so they cannot get cancelled out. Okay, okay, so this will become cos x plus 1. Cos x plus 1 is equal to 2 cos square x by 2. Okay, 2 cos square x by 2. This is your second equation. Now we have got two equations which give us the value of 1 minus cos x and 1 plus cos x. Okay, now these two values we are going to substitute it in the this one equation. Okay, so this was all, you can say, a side step. The main step is over here. So this is your dy by dx. Okay, now you need to substitute what is the value of 1 minus cos x. The value of 1 minus cos x is 2 sine square x by 2. Okay, and what is the value of 1 plus cos x? The value of 1 plus cos x is 2 cos square x by 2. We know that tan x is equal to sine x upon cos x. Similarly, sine square, this 2 and 2, it will get cancelled out because they are the outer substituents. Now dy by dx, it gives us tan square x by 2, because tan square x by 2 is equal to sine square x by 2 upon cos square x by 2, right? Now what will happen further is now we are going to separate. Okay, separate the y and the x all together. Okay, what is the y and the x all together? This is your dy, so we will do this tan square x by 2 dx. We are going to separate this y and we have separated this x altogether. Now we will do integration. Now that they are separated, we can do integration of them. Integration dy is equal to integration tan square x by 2 dx. Okay, now what is the identity related to this? Okay, we can use like one more identity, like this is the identity sec square theta minus tan square theta, it is equal to 1. This is a very old identity that we have known. Similarly, sec square x by 2 minus tan square x by 2 is equal to 1, and we are asked about tan square x by 2. So sec square x by 2 minus 1 is equal to tan square x by 2, right? We are going to substitute this thing over there. sec square x by 2 minus 1 is equal to tan square x by 2. We are going to substitute this thing over here. Okay, so integral dy is equal to integral, we will write sec square x by 2, sec square x by 2 minus 1 dx. Okay, we have written this. Okay, now what further will happen is, this is your dy, we can write it as y. Okay, integration of dy as y. Okay, and sec square x by 2, when we do this, okay, there is one more important thing over here. When you are, okay, one is the formula. Let me write the formula first of all. Integration of sec square theta is equal to tan theta plus c. Old formula again. Okay, integration of sec square theta is equal to tan theta plus c, where c is the constant. Okay, this is the same formula we are going to use. Sec square x by 2, it is going to give tan x by 2. Okay, the another important thing over here is that in differentiation what happens is, when you do differentiation, okay, when you do differentiation, then the 2 will get multiplied, but when you do integration, then it will become 1 upon 1 by 2. Okay, the x, okay, let me write it. Sec square x by 2, it is going to give tan x by 2 plus c, right? That is what it is going to give, right? But over here, you will need to do like of this 1 by 2. So how you will do it? You will write into 1 upon 1 by 2 like this, in this format. Okay, 1 upon 1 by 2. Why? Because if it was differentiation, then so you must have directly multiplied it by writing 1 by 2. Okay, but since it's an integration, you will divide this 1 by 2. Okay, in the downside, in the denominator. So sec square x by 2, what it is going to give you? Sec square x by 2, it is going to give you obviously tan x by 2 multiplied with 1 upon 1 by 2. Okay, I already told this, that in differentiation 1 by 2 is directly multiplied 1 by 2. Okay, but in integration it is divided. In integration it is divided. Okay, now what next? Obviously the constant will come, but before the constant, over here you see this is minus 1 dx. So you will write it as integration of 1 as x minus x, and what is the next? Constant x minus x plus c. That is important. Okay, so I think that maybe this was a part where you got stuck, but it is actually easy. The integration of sec square x by 2, it is going to be tan x by 2. And always in differentiation 1 by 2, if it was differentiation, you must have directly multiplied 1 by 2. But since it's integration, you have divided 1 by 2 over here. Okay, that is the only difference. Minus x plus c. Integration of 1 is x. Okay, and this constant, it will come with the formula always. Okay, like where is the formula? Over here, right? Yeah, this formula plus c, it will always come. Okay, here. So now we can just simply like, okay, in the question we were asked general solution, right? We were asked the most general form for its solution. So what is that? That is y is equal to 2 tan x by 2 minus x plus c. This is the final answer. 2 tan x by 2 minus x plus c. So I think this question was easy. I can again repeat it if you want. This is the question number 1 of exercise 9.3. dy upon dx is equal to 1 minus cos x upon 1 plus cos x. I said to make the question easier, you should always focus on the angles. This is the angle, this is the angle. Okay, what I said, you need to convert this x to 2x. Now identity related to cos 2x is 1 minus 2 sin square x and 2 cos square x minus 1. Okay, you need to simplify this identity. You will specify the angle 2x and you will divide it by 2. Okay, so you will get this identity, cos 2x upon 2, and this all. 1 will not get divided by 2 because it is a substituent and we are focusing on the angles. Angles between the brackets, within the brackets. Within the brackets, those angles, they are going to get simplified, they are going to get changed, and they are going to be converted. Nothing will happen to the substituents or the outer world. These brackets will only get divided. Okay, understanding? So that is the conversion of cos x, and you will get this identity 1, and similarly 2. And then this was the identity which you want, which you need to learn. Sec square theta, its integration is tan theta plus c. Okay, and this is the old identity, sec square theta minus tan square theta is 1. So you can just substitute the results. Okay, and over here, so dy and dx, you need to separate them. I said over here. Okay, here was substitution. Okay, you did substitution here, and over here simple identity was applied. Tan x is equal to sin x upon cos x, and then what you did, you separated y and x. Okay, this is y dy, and this is x by 2 and x. Okay, so integration now you can do when they are separated, x and y are separated. Now you can do integration. Integration of dy, y you will get. Integration of tan square, first of all you will convert this tan square x by 2 using the identity, old identity, sec square theta tan square theta is equal to 1. This old identity, using that you will simplify it first of all, and then integration of sec square theta, it is tan theta, and it will be divided by 1 by 2. Okay, and then integration of 1, it is going to be x minus x plus c, because there is minus over here, so that is my minus x. Okay, now the general solution, you this 2, it will go up over here, then it will become 2 tan x by 2 minus x plus c, right? This was an easy question. Okay, thank you.